The robot command the robot command data access. This file acts as the translator between my C hash code and the PostgreSQL database. It uses the npg SQL library to open a pipe to my server. Inside, I have written logic to perform CRUD operations. It can fetch all commands, find a specific one by ID, or update existing ones. It is written with security in mind. By using parameters, it ensures that any user input is treated as data rather than code, which efficiently block SQL injection attacks. Map data access. Similar to the robot data access file, this class specializes in managing my grid data. It handles the mapping of database rows into C hash map object. It is responsible for saving the number of rows and columns for each map and ensure that when I retrieve a map, its description is handled correctly using db null check. The file ensures that my coordinate checking logic in the API always has the most up-to-date map dimension to work with. Controller.cs. This is the front door of my backend for anything related to robot instructions. It defines the endpoint URLs that a user or a front-end application would call, such as get API robot command. Instead of including a list of commands in its own memory like in previous task, it now calls the robot command data access method. This makes the controller statelet, meaning it doesn't care if server restarts. It always gets the truth directly from the database. Map controller.cs. The controller manages the special data of my application. It provides endpoint to create, view, or delete maps and includes special logic like check coordinate. This specific endpoint takes an x and y coordinate from the user, ask the database for the maps dimension via the persistent layer, and then calculates if those coordinates are within the boundaries of the grid. It serves as a bridge between raw database number and functional application logic. So this is my PostgreSQL setup. As you can see, the table for left with entries left, right, move, place, report. That's it.